Okay, welcome back. 3.5, talking about the idea of applications of rational functions. So we're going to take a look at these rational functions in a word problem format. While there are numerous different types of word problems we could focus on, we're really just going to focus on one type, and that's the idea of a mixture word problem. It's a pretty classic rational function. The format you're going to want to use for each of your mixture word problems is these two fraction equations. So the top of the left fraction is your sum of the parts of the mixture. The bottom left is the total amounts of the mixture. And then the other fraction is the percent concentration over 100. And you'll be asked to find one of four possibilities. And we're going to do four examples to kind of show how each of those things different works. The idea of the sum of the parts, this is going to be the individual per concentration percent times its individual amount. They'll be all added together, whereas the total amount of the mixture is all the amounts of each thing added up for the total. And the percent concentration, if the mixture is 70%, it'd be 70 over 100. So the idea is, again, you're just make sure you're careful with the percents, write them as decimals there when you're working through it, except for, again, the overall percent concentration. You're going to create some sort of algebraic expression somewhere. And somewhere will be the unknown x. Typically not a quadratic. Linears, yes. Quadratic, not really common for something like this. So, for his birthday, Peter mixed 2 gallons of brand A fruit punch and 8 gallons of brand B fruit punch. Brand A contains 25% fruit juice and brand B contains 5%. What percent of the mixture is fruit juice? So the idea is we're trying to find the percent mixture. So that's our x over 100. And then so the concept of having the sum of the individual parts is we know that brand A, there's 2 gallons. And brand A has got 25%. So it's 2 times 0.25. And then brand B is 8 gallons. Its percentage is 5%, so it's 0.05. Make sure you are careful with single digits decimals there. You want to make sure that if it's 5%, it's 0.05, 7% would be like 0.07, stuff like that. And then the total amount is the 2 gallons and 8 gallons added together. So we'll find when we multiply the 2 times the 0.25, the 8 times the 0.05, and add that stuff together, we're going to get a 0.9. And 2 plus 8 is 10. So when we cross multiply, we get 10x equals 90. So x is going to equal 9, which means that the percent mixture is going to be 9% fruit juice. Okay, so remember that x in this case is the percent concentration. So we need to make sure it's setting up and being written in that correct type of way. All right, so next up we have this scenario. So we have how much soil with 35% clay do you need to add to 4 cubic feet of soil with 25% clay to make soil with 27% clay. So we're trying to find an individual amount now. We don't know the amount that goes with the 35%, so that's going to be 0.35 times x. We do know that there's 4 cubic feet of soil that goes with 25%, so it's 4 times the 0.25. The units don't actually matter, so we're not like cubing something or whatever. And again, we don't know the individual amount in the 35%, so it's x plus 4 for the 25%. And the overall mixture's got 27%, so it's 27 over 100. You'll know, there's a couple different ways you'll know the 27% is the overall mixture. First off, context clues, reading the problem. You're making soil that's 27% clay. That's the mixture. We're putting things together to create that, so that's how you'll know. And the other way you'll know is if there's 3%, the mixture has to be the middle of the 3. It's impossible to mix 2% together and get a percent that is either greater than both of them or less than both of them. It has to be in the middle. So that's why, another reason why you'll know that this is going to be in the middle right here. So we go ahead and start solving this stuff out. We have our 4 times the 0.25, which gives us 1. So we have 0.35x plus 1 over x plus 4 equals 27 over 100. We cross multiply. We're going to get 35x plus 100 equals 27x plus 108. Solving, we'll subtract 27x, get 8x. Subtract 100 to get 8. Divide and get 1. So there's going to be 1 cubic feet of soil for the 35% clay. Because again, you're solving a word problem. X is not part of the original word problem, so you can't really just stop at say X equals 1. You need to describe what this answer actually represents. And it represents 1 cubic feet of soil. That's going with 35% clay. That's its description. That's what I'm looking for that kind of answer. So another possibility is we don't know the individual percentage for one of the mixtures. And they tell us Andrew made a nut mixture, contains 42% peanuts, mixing 15 ounces of mixed nuts, contain 22% peanuts, and 10 ounces of a different brand of mixed nuts. The second brand contained what percent peanuts? So we know that the 22% goes with the 15 ounces. So we have 15 times the 0.22, and the 10 ounces goes with an unknown percentage. And we know the two individual amounts are 15 and 10. The mixture is 42%. And then again, they literally tell us made a nut mixture containing 42% peanuts. That is the overall mixture right there. So we go ahead and multiply the 15 times the 0.22, getting 3.3 plus 10x over 25 equals the 42 over 100. You are welcome to reduce 42 over 100. It's possible. Just not really necessary. A lot of times you want to leave it as over 100. So when it cross multiplies, it better cancels any decimals you have in the cross product. So 3.3 times 100 gives us 330. And then 10x times 100 is 1000x. And then 42 times the 25 gives us 1050. Subtracting over the 330 gives us 720. Divided by 1000 gives us 0.72, which means this is 72% peanuts. Okay, so when you're solving for the individual percentages, you are going to get a decimal, and therefore you need to convert it to the proper percentage. So that's why 0.72 became 72%. If you're solving for the percent mixture, if I go back a second to example 1, you'll notice we didn't write that into its percent form. 9 does not become 900%. First off, that would make no logical sense. And then second off, the x is part of x over 100, so it's already written as its percent right there as that number. So it's not in a decimal form like we have for the 0.25 there and 0.05. And same thing here. The x is part of the decimal portion of it. That's why when we get a decimal, we convert it back to the proper percentage. So just be careful with that. Now our last scenario is one that's going to create kind of a system here. Because they tell us to build a garden of your dreams, you need 7 cubic feet of soil containing 26% silt. Two types of soil can combine this. You can combine to achieve this, so 25% silt and 32% silt. How much of each soil should you use? So we have two unknowns. We'll label x as the amount that goes with the 25%, and then y is the amount that goes with the 32%. So we know that we're going to have a 0.25x plus a 0.32y over the x plus y, and we're creating a mixture that's 26% over 100. Now, you might be looking at this going, okay, I've got two unknowns but only one equation, so where's my second equation? And that's this concept right here. They tell us that we need 7 cubic yards of soil to create this, which means x plus y has to equal 7. So I can replace the denominator with a 7, and then we can choose to replace either the x or the y. It's kind of up to you which one you want to go with. Let's just say x equals 7 minus y. Let's replace x. So that means this becomes 0.25 times 7 minus y plus 0.32y. I will typically try and replace the variable that has the smaller percentage. That way I don't get a negative in the problem, which can kind of throw things off a little bit if you're not careful. But it's not going to give you a wrong answer if I replace the y instead. I said y equals 7 minus x. So we distribute that. We get a 1.75 minus a 0.25y plus a 0.32y over our 7 equals 26 over 100. Combining the y's, we'll get 1.75 minus 0.07y. Sorry, plus 0.07y. Sorry about that. Over 7 equals 26 over 100. Cross multiplying, we get 175 plus 7y. 26 times 7 is 182. Subtracting, we get 7y to equal 7, which means y is 1. So if y is 1, x is 6. So we're going to have 6 cubic yards of the 25% silt. And then we're going to have 1 cubic yard of the 32%. cells. Again, always make sure you're describing what your answer actually represents. All right, so just make sure you're careful in that particular word problem scenario with how you're setting up the variables and then where you're setting up your second equation from. All right, so that's our word problems. There are other types of rational function word problems, but just kind of, make it so we're not going through like hundreds of different word problem types. We're just going to focus on this only one, the mixture of problems right here. One last topic in Unit 3, we're going to talk about graphing these types of rational functions. So I'll see you next time with that video.